Hi friends, greetings. Last class we discussed about the states of power system. So we know how the 5 states are classified, how we maintain the normal state, okay. So always and depend on certain qualities, that is certain constraints we should maintain, okay. So coming for next topic today, it is objectives of power system control, okay. The fundamental requirement of maintain the power system controls, we require certain objectives. So in that we are listed out certain objective here. So one is to meet the changing the demand in active and reactive powers. Of course, when you sudden variation in the load in a system, so it should be maintained stable condition at the moment to meet the demand in active and reactive power. So it should be balance of your reactive power and also to maintain the stable in the system. That means the quality of the power should be maintained. Okay, that is nothing but a sinusoidal waveform. It should be maintained in proper desired manner. Okay, so next, this is the first objective. So when you go for second objective, power quality, we know that. So we should maintain power quality is very important objective when you go for the power system operation control is considered. Okay, the power quality always should be certain parameters should be considered. It may be voltage signals or current signals. Maintain the power quality, power reactive power controls. Everything is come under power quality, and also reduce your harmonics. So you should not apply more harmonics here. So that all covered by the power quality. Okay. So another objective here it is energy should be supplied at minimal cost. Okay. What is this? Okay, so whatever the energy you are sending and sending supply to the customers, it should be in minimal cost. Okay, and the view of this, okay, and the view of this, we have to discuss all this consider with the use of this diagram. So there is this diagram represents the various controls in power system. Okay, so imagine we have the network. Network means there is a prime mover and generation, this is a transmission and load. Okay, this is a setup we can observe in the power plant. Okay, so prime mover already we know that prime mover we are using it maybe in the hydro power plant we are using water as a resource for input fuel, and thermal coal is the fuel. So turbine, it will rotate. Turbine is connected to the generator, that is nothing but coupled with the generator, and generator whatever the generating the power it transmitting through transmission lines, and load is consumption in the distribution level. But here it is, so mainly you have to control the power system objectives and power quality, all these things, and all this to satisfy these objectives. So first you see here prime mover, generation and load, and there is a one system for connected to the generation that is called excitation system. So excitation system is again it is control the voltage level of the generators. Okay, when you see the block diagram here, so imagine that, keep it in your minds, there is a power plant. In the power plant generator is there, it's running, power is generating, the power is after generating the power it will transmit in the long transmission line and loading. But variation in transmission line it is disturbed to the, of course, in both the sectors. Okay, any variation in the transmission line voltage, for example parameter is voltage, it will affect on the generators. So when it is controlled through excitation system, okay, and the more variation happened, it will, suppose frequency variation happened, it will affect on prime movers. Okay, so of course if more variation of frequency, it will affect on the turbine coupling, so we will get maybe damage if more variation. That is the reason we should carefully control these parameters. Coming here, so this block represent system generation control, load frequency control plus economic dispatch. Okay, system generation control, load frequency control plus economic dispatch. So these blocks represent, these are schedules. Okay, and frequency, tie line flow and power generation. Okay, so what is frequency, tie line and power flow? Tie line flows obviously, so I told you about one state to another, entire it's connected one region to another region through tie line power. So because the entire nation is in one single loop, so that time to transmit one state to another state, definitely we are using tie line for exchanging the power from one grid to another net. That's called, we can say, from centralized group we have global of simple every state having their own grid. So we are interconnected through tie line. Again, frequency you have to monitor and power generation. Okay, these are schedulers. When the power will be connecting, when the load is be demand will come, we don't know, because whenever the various demand is varies, so it may be suddenly variation happening, it may be slowly, it may be they will schedule like this. Okay, so today 6 to 7 we have demand will be more, like that. Before only schedule, certain time suddenly variation of load will be more, so that moment, so meet the changing demand in active and reactive power should be maintained. Okay, so coming for supplementary control, we are going to see, so all these parameters we have to monitor through this and control from this. Okay, so these are supplementary control, so all the data or signals to connect to here. Okay, so this is the prime mover of the control. Okay, I told you this is the prime mover of the control, I can say this is, and this is excitation system, I told you. Okay, and this is okay, speed of the generator, and this is a PG generating output from the generator. So output is connected to transmission line, obviously. So in the transmission lines, we should controlling devices certain we have to use it. Okay, because parameter should be maintained. So otherwise what will happen? So any variation happen, it will affect on this, of course. Okay, so whenever the voltage is variation, definitely there is a excitation system. See here, so this voltage is happening, I can connect like this. Okay, so whenever the voltage variation happen in generators, so how voltage will be variation? Definitely the transmission lines. So because depend on the load. So parameters are various. These can be controlled through certain devices or techniques. That is nothing but transmission control, voltage control methods. Okay, with use of series capacitance connected in parallel capacitors and a transmission line. So this can be controlled, and this is nothing but your reactive power control or nothing but VAR control. So these are some of the methods we already studied in the previous semester. That's the reason why I told certain prerequisites are required for this subject. Okay, so certain reactive power controls are also available, and HVDC and FACS. So we know that. So high voltage DC transmission and flexible AC transmission. So here, to include these controls, we can maintain the quality of the power and stability of the system. So that we can I can say here. Okay, so see here, any variation happen, suppose load is variation, so this will be control, take care of that. Okay, so certain any small variation happen, definitely we have control of spinning reserve. Okay, it should be in spinning reserve control. Your generating should be in spinning reserve. When you take for previous class section, so normal state and alert state, extreme state, so all parameters should be in limited version, it not cross the margins. That is nothing but your spinning reserve. So it's limited of spinning reserve. When cross the spinning reserve, definitely it will go to extreme state and emergency state, and of course we know that. So these parameters can be controlled mainly on through this system. This system we can observe in generating station. When you visit to the power plant, we can observe this. And this is again from output of the power plant. This completely we can observe in transmission section. Okay, so all these techniques they are using, or equipment they are using to control the parameters mainly on voltage at the transmission level. And if the major load is varies, definitely will affect on frequency. Once you are affected, it affect on the turbine. So turbine, because we are going to coupling to the generators, because of speed varies, we can see here, observe here. When the load is putting more on the demand is increases, definitely drawing the power is more on the transmission line or distribution line. So at the two moments, voltage should be reduces, obviously current increases, and also speed should be increases, and the speed should be speed is decreases due to speed decreases. Okay, so definitely if voltage decreases, this system should be taken. But also this is also in limited conditions. We can't more than cross the limit. It should be in margin conditions, because the switch gears and devices all are in margin conditions. Should not cross that one. If we cross, definitely again your system should be go to emergency and extreme state. And speed is varies here. That is, again, we'll take back feedback of this and connect it to the system. So prime mode, again, then if it is a hydro power plant, they are going to servo motor control. For water jets, they are going to control the speed of the turbine. Okay. Obviously, in thermal power plant, they control the steam. Okay, steam of the turbine. Based on that, so all control system like embedded systems are involved here more than electronic devices and certain software like SCADA systems and AGC, especially on AGC system, they are involved and controlling these type of things. Okay, so majorly we are going to concentrate on three. One is stability here, and reliability and security. So 3 points to be remembered. Okay, so obviously security is, we have to secure entire system with the use of certain devices, and stability represent, we know that any obstruct, that means in any abnormal condition and normal condition, it should be stable. And reliable represent, so it will be long run, even though it efficient way. Okay, long run with efficient way. So with the use of these three terminals, security and stability and reliability, SSR. Right. So these are the fundamentals, objectives of the power system control. Okay. So this diagram represent various control methods used in power system especially, and these are the fundamentally we are going to use, and these are all the controlling devices used at the controlling device used at the parameters at the transmission levels. Okay. So FACS, flexible AC transmission lines, means series control, series control, series parallel controls. Okay, TCSC and SVC, UP, triple SC and UPFC. So all these certain things, these type of control we are going to use. And HVDC transmission, we know that. Okay, long transmission line, we are going to use HVDC system. Okay, converter station we are going to set up at the sending end as well as receiving end. And certain things are controlled through reactive power and active power, means so VR controls. They are connected to even XC or XL both in a system. If more voltage is more in the system, it will observe. If shortage of resistance, definitely capacitor banks they are going to use and boost up the lines to maintain stable conditions. So stability definition, it's an ability of the system to stable in both normal and abnormal conditions. So entire things can be observed mainly on to maintain the stable conditions. System should be always, you should maintain normal state. Okay. Hope certain things today we have discussed. Hope for the best you have understood how objectives should be defined to control the power system. Okay. So thank you very much for listening this topic. Namaskara.